Okay, can you see my screen? Is it visible?
Yes.
Okay, thank you. So let's go. So basically today I discuss about that land use land cover change detection, how we can easily perform the land use land cover change detection for different decade, suppose 1990 to 2020. So this time period how much land coverage changed. So we try to compute this type of area, as well as also NDVI change detection. We'll also discuss about that, how we can easily monitor the NDVI change detection, and also NDVI classification. So how we can easily make the NDVI classification and extract the dense vegetation and thresholding technique. Also discuss about that, as well as class wise land use land cover change detection in one level. Also discuss about that, calculate the transition area, and this is the very important topic. So urban development or urban growth monitoring. So how we can easily perform the urban growth monitoring, we also discuss about that. So let's go. I'll try to show you that all of those step by step. So then I hope we can easily get the idea how to work. Okay.
Okay.
Okay, so let's go. So here I already developed this type of code. If you check, here I already developed some code for my previous. Suppose you can see, this is the one kind of land use land cover classification. So I already make this type of land use land cover classification map because I want to show you the change detection. And previous class I discussed about that how to make land use land cover map, okay, using the machine learning model. So here I make the map. If you check, I create the two land use land cover map. So first map is for year of 2023 and another map is 2013. Okay, so if you check, I create the two decades land use land cover mapping. So this is the map for year of 2013. Okay, and this is the map 2023. So now I create these two types of map. So now between these two map I want to find out the change detection. So how much build up area increasing or how much sand land is decreasing. So this type of analysis I will try to show you that step by step. Then I hope you can easily get the idea for change detection. So let's go. First of all, if you check the code, so we already discussed about the land use land cover classification, how to make the land use land cover classification. I detail discuss in our previous classes. So you can simply check the class, then you can easily get that idea how to make different types of machine learning model and develop the different types of land use land cover classification. Okay. So today's session I discuss about that how to make the change detection. Okay. So if you check here, I already completed the code and also check the accuracy of the land use land cover for 2 time period. So I find out that 98% accuracy, as well as also find out the another map for 96% accuracy. So it is very better, no problem. So now we try to find out the change detection. Okay. So change detection, it can be two types of change detection. One type is called the single class change detection. Suppose in this case, I have total 4 class in this map. If you check, red is indicating about the build up area. Then this type of gray color indicating about that sand land. Blue color is the water body and green color is the vegetation. Okay, for my map. So change detection, it can be two types. First type is the single class change detection. Just I make the change detection only for the one class. Suppose I want to make the change detection for the urban. So urban change detection I want to monitor between this time period. So then it's called the urban change detection map. Okay. Suppose you want to focus only for the vegetation. Suppose I want to check only for the vegetation change detection between this two time period 2013 to 2023. So then we are just applying this only for the vegetation. So it's called the single class change detection. It can be urban change detection or water body change detection or build up change detection or vegetation change detection. Okay. So in this case, I discuss about the urban change detection, how we can easily perform the urban change detection between this time period 2013 to 2023. Okay, so I'll try to explain these things, then you can easily get the idea how it will work.
Okay. Listen to.
So first of all, we simply take a variable. If you check, we simply take a variable. I put the variable name, suppose build up area 2023, and I call the classified one. Okay, this classified one, this variable stored the map of land use land cover 2023. Okay, this variable, it stored LULC map 2023. Okay, so just I simply call the classified one, because this classified one is stored the land use land cover map 2023. If you check the variable, suppose if you check, I just use this variable to make this stored this map land use land cover 2023. If you check the classified one, okay, so this variable is stored the land use land cover map 2023. Okay, 2023 it is stored in this variable. So just I simply call this variable name, and then set equal to 3. Why I put the 3? 3 is the class number. If you check, when I take the training sample, I take the vegetation, water, sand, build up. Okay, then vegetation, water, sand, and build up. So if you check what is the build up class number, is 3. Okay, so I want to work for the build up change detection, so just I put the 3. Suppose when you work with the water, then simply change it 1, because 1 is the value of this. Okay, so now I just work for that urban or build up, so just I put the 3, because 3 is the class number. So now further we try to display the map only for the urban. So for that I simply add a layer, map.add layer, and call the build up area 2023, and then simply show the urban area as a red color and non-urban show as a gray color. So now if I run the code, then it display the map only for the build up. Okay, it's added another layer. If you check, it's added another layer, urban 2023. So now if we check, we can get only for the urban map. So this is the urban map in year of 2023. Okay, so I just create only for the single class map. So this is the single class map of urban in year of 2023. Okay, suppose now I want to create the single class map of suppose vegetation. So how I can create? Can you get the idea how we can easily create the vegetation? Any idea where we need to change for vegetation?
Classified the fruit.
So we need to change in here class number. So let's check what is the class number of vegetation. So this is the 0. Okay, so when I put the 0, then we can get the vegetation map. Just I put the 0, and now I want to show the vegetation as a suppose green color. So I simply change it green color. So now run the code. So now it display the vegetation map in year of 2023. Okay, if you check our first layer, it show the vegetation map in year of 2023 as a red color, sorry, green color. Green color display the vegetation area. Okay, we find out this the gray color. Gray color, there is no vegetation, and this type of green color have the vegetation or vegetation area. We find out in year of 2023. So this is the one kind of process to make the single class map. Okay, sometime we need to work with the single class. Suppose you just only work for the vegetation, so we can see, this is the green color is the vegetation. Okay, So this is the process. We can easily make the single class map for any land use land cover. Okay. Suppose I want to I need the map for water body, only for the water body. So how I can choose it? So let's check what is the value of water. You can check what is water value is the 1. So just simply
Yeah.
change the value. Suppose I put the value is 1, and I want to set the water body color as a blue. So just I put the blue. So now run the code. So now we can find out the result in water body map in year of 2023. We find out. So now we find out this type of blue color have the water body, okay, and this type of gray color there is no water. It's other class. Basically, this is the water and non-water. So now I want to work with build up because I want to make the urban change detection. So that's why I need to put the urban value or build up value. If you check build up value is that 3, okay. So just I put the build up value is the 3 in here, 3, and I want to display the build up area as a red color. So just put here the red and run the code. So now it display the build up area map in year of 2023. So this is the process to make the single class map after making the land use land cover classification. Okay, so now you find out this is the urban map in year of 2023. So now I want to calculate how much urban area are available in this in year of 2023. How much urban area? This type of red color is the urban area or build up area. So now I want to compute how much urban area is available in here. So for that, just simply use a variable. Suppose I put the variable name is the urban area, and I call the build up area 2023 multiply with this function, okay, ee.image.pixel area. So this function basically compute the pixel area in square kilometer unit. So further we simply display the value using this code. It's called the reduce region, okay. So reduce region is one kind of function. This function help you to compute the total pixel area. So in this case we are just calculate the total pixel area of build up for this boundary we try to compute. So further I simply apply the reduce region function, and I call the urban area. This is the urban area. Apply the reduce region function, and I calculate the total area. So just I put here e.reducer.sum to compute the total area. And ROI, it's my shapefile variable name. Okay, if you check my shapefile variable name is ROI. So just I put here the shapefile variable name is the ROI. So this variable name I simply put in here as a ROI. And then further we try to print how much build up area in 2023 we try to compute. Just run the code. So now it compute the total area of build up in year of 2023. So it computing how much area is available. Okay, so we find out the result. If you check, this result show as a square meter unit. Okay, it's a square meter unit. So I want to convert into a square kilometer unit. Okay, so let's go try to convert. So for that, just take a variable. So I put the variable name, suppose urban area 2000 square kilometer. You can put any variable name, and I call the variable name area urban to get from this classification. I put this name classification and then divided this value to convert the unit a square kilometer unit. So now further we try to print this area and run the code. So now it's compute the result in square kilometer unit. So now let's check what is the result of a square kilometer unit.
So we try to calculate the available area.
Yes, how
And,
much area is available in year of 2023 for urban?
Yes. For urban, so it's the gray area who isn't built up.
Yeah, build up.
Okay.
Yeah, because in this time we talk about the urban change detection or build up change detection between these two time period. Okay, for single class change detection, only for the single class we consider, as well as we can also do for the multiple class. Suppose at the same time all of class we consider, suppose vegetation, water, sand, and build up, and make the change detection. But first time I try to show you that only for the single class change detection, suppose urban change detection between the time period 2013 to 2023. Okay.
Yes.
So now we find out that how much urban area in 2023. We find out the urban area 2023 is that 824.99 square kilometer.
Yes.
So this is the result of urban area in 2023. We find out a square kilometer unit. So now these same things we are just applying for land use land cover 2013. Okay. So now I want to calculate how much urban area is available in year of 2013. Okay. Because we already calculated the 2023. Okay. Just apply the same process. So first of all, just take a variable. Suppose I put the variable name is that build up area 2013 and I call the classified. Why I call the classified? Because this variable stored the land use land cover map in 2013. Okay, this 2013, this map is stored in this variable, classified variable. Okay, so if you check the variable again, suppose I will show you that. If you check, yeah, so this one you can classified, this variable stored the land use land cover 2013. Okay, so just I call the land use land cover 2013 because I want to compute the build up area in year of 2013. So further I simply classified and set equal to 3 because 3 is the value. 3 is the value of build up. So just I put the 3. So now make the map of build up and non build up in year of 2013. So now run the code. So it's just create the map of build up in year of 2013. If you check the value, so now it's create the another urban map in 2013.
But what I try to understand is that the number calculated is equal to the red pattern or the gray.
So gray is that non-build up. You can put any color.
Yes.
There is no problem. But in this time we put the gray color as a non-build up. Okay, if you check, suppose I put the gray, you can put any color. Okay, gray is the non-build up, red is the build up. We make the two binary class. Gray is the non-build up, red is the build up. But you can put any color in here, there is no problem. So now we find out this type of map, land use land cover map in for urban. it's show the two map. If you check urban area in 2013 and urban area 2023, okay, you can see the difference between the two map. So we find out that urban is increased. You can say urban is increased. Urban is increased in 2023. We find out urban is increased. So now we compute how many area increased in urban.
Yes.
And where the urban is increased, we try to detect this type of area. So let's go try to detect the area and also compute the area of urban in 2013. Same process, just apply. Just take a variable urban area to then call the build up area, multiply with this function, okay, to compute the pixel area, and further apply the reduced region function, calculate the total area in our study area, which is ROI. This is the scale for Landsat satellite imagery. Just I try to print the area and also convert the area in square kilometer unit. Okay, just simply convert. So now run the code. So now it's computed the result. How many urban area in 2013? We find out. It's working. Okay, so we find out that 586 square kilometer area urban in 2013. Okay, and we find out that 824 urban area in year of 2023. Okay, so how much urban is increased? We find out the almost 238. Okay, 238 is square kilometer area urban is increased. Just simply subtract this value. This is the result in year of 2023 and this is the result of 2013. Okay, for urban, only for the urban. So now I want to check, suppose another class, same process. Suppose I want to check for how much sand land decrease between these two time period. Okay, so let's try to show you this process. Same process, just simply change in here. Just put the sand value. So what is the sand value? If you check, sand value is 2. So just I put here 2. Okay, so now also put in here 2. 2 is the sand land. Okay, just run the code now. So now we find out that how much sand land is decreased between this two time period. So now if you check, we find out this type of map. So just show the result first. How much sand land is decreased. We try to check it. Okay, so you find out, you can see. This is the result in year of 2013. 13, and this is the result for year of 2023. Okay, so now if you check, just simply subtract these two value. 253 sand land is decrease. Okay, so this value subtract with this value, then we can get that how many sand land decrease. 253. Okay, 253 decrease the sand land or lost the sand land between these two time period, 2013 to 2023. This is the result for year of 2023, and this result for year of 2013. Simply subtract this value and this value, then we find out that minus 253. So minus 253, it means that barren land or sand land is decreasing between these two time period, and this is the decreasing total 253. Okay, so now in this case I want to work for urban, so just I simply put the urban class. Urban class, it's mainly your class number 3 class number, so just I keep the 3 because I want to make the change decision for the urban. Just I put the class number 3. So now we can easily find out that how many urban area is increased between these two time period, 2013 to 2023. Almost 238 square kilometer area is increased between these two time period, 2013 to 2023. 238 square kilometer area of urban is increased, and 253 barren land or sand land is decreased. This is the result. We find out the 586 in 2013. And this is the result year of 2023. So how much increasing? 238. Simply this value and this will subtract, then we can easily get the result. So now I want to identify change detection map of urban. Okay, suppose where newly set up urban is, okay, and there is no urban, so we try to identify change detection area of urban. So for that same process, just apply to make the change detection or urban change map. Just take a variable urban change map, so then call the build up area 2023, this variable build up area 2023, this variable build up area 2023, subtract with build up area 2013. Okay, so now just I want to add the map. I want to check the urban changed map. I want to add, and I put the pink color, and it show the urban changed map. Okay, where newly set up urban we find out. So now run the code. So you can see we find out this type of pink color, it's indicating about the newly set up urban area. Okay, so this type of place there was no urban. in year of 2013, but 2023 we find out the urban area, this type of pink color area, we find out the urban area. Okay, this is the urban changed map. If you check, we find out this is the urban area 2023. And when I check the changed map, urban changed map, we find out this type of place, it's a newly set up urban area, this type of place. Okay, because if you check 2013, in 2013 there was no urban. In 2013 there was no urban, but 2023 we find out the urban, this type of place. So this is the urban expansion map. If you check, so this is the result, this is the result for 2013, but we find out the 2023 we find out this type of place is urban increased, this type of pink color, this type of place urban is increased. And how many urban is increased? 238. Okay, simply subtract this two value, simply subtract this two value. If you check this two value, 824 and 586, then we find out that 238 square kilometer area of urban is increased. And this is the place, this type of place, we find out the increased urban area, this type of pink color indicating about that. Okay, okay, thank you. Okay, so we find out this type of place is urban is increased, but in year of 2013 there was no urban. This type of place is totally blank, it totally barren land or sand land, but in 2013 we find out the urban. So this is the newly urban, or this type of place we find out the change of urban, mainly newly set up of urban. And how much urban is increased, we find out the result, just simply subtract, this is the result 2023 and this is the result 2013, simply subtract these two value, we find out the changed area of urban. So this change area we can also calculate it in here also. Okay, suppose this is my changed map. Okay, changed map basically it show the result for your only for your newly set up urban area. So I want to compute the area. So for that, just apply the same process, just take a variable, suppose urban change area, then urban change map, multiply with this function, then compute the total area, just simply compute, and also compute the square kilometer area also. Okay, so now you find out the result, basically the result to subtract this will find out the urban changed area result, we find out how much change area of urban. We find out this type of result, 357 urban changed area we find out between these two time period. And in this case you can see it show, because in this case we put the scale value is the 100 meter. So when you keep the 30 meter, then we find out the more accurate result. Basically in this time it show the some value is also high, because we put the 100 meter scale area. So just try to run 30 meter scale and then check what happened. Okay, so if it's some problem when you work with big study area and put the scale value is low, then if it's not work, so it's one kind of limitation. But when you increase the scale value, then it will be okay. So now let's check what happened. So you can see find this type of problem. Okay, so user memory limit exists. So then when you just increase the value 100 meter, then you can find out the result. But we face some error on this result because in this time we have increased the scale value. So we find out the result. Urban changed area between these two time period. And this is the urban changed map. And now how I can make the urban expansion map. Suppose I want to, if you simply search on the Google, urban expansion. So if you check, we find out this type of map. Let me show you from here. So you find out this type of map. Okay, let me open the paper. So this one kind of paper, mapping urban expansion, exploring its driving forces, the city of Peru. So if you check this paper, okay, in this paper, basically you can see they are make the change detection from 1969 to 2015. Okay, so this is the time period about there, and they are apply the result. If you check this type of figure, why it not showing? Okay, just a minute. Let me show the another one. Okay, so this one you can see. So this is the one kind of urban development or urban expansion mapping. If you check, so this is the urban result in 1975. This is the urban result in 1990. This is the urban result 2010. So urban is increased. We find out. Okay. So this is the urban expansion. So when you work with urban expansion, suppose in this case, I just work only for the 2 decades, 2013 and 2023. So you can also add the more decade, suppose 90, 190, then 2000, 2010, then 2000 of 20. Okay, this type of decade we can also add and make the more better urban expansion mapping. So if you check some research paper or research article, so basically they are using the multiple year or multiple decade to make the change detection. So in this case, just I show you this example only for the 2 decades. So you can also try to add the more decade to when you work with your real time or when you work with the research paper. Try to add the more decades to get the better result for your urban expansion or urban development. So try to add the more year. So in this time I just make the year 2013 and 2023. Then when you work, you can also add the more. So now we can find out this type of result. If you check, this is the urban map 2013, this is the urban map, and this is the urban map to 2023. So I want to make the urban expansion map easily from here. So we need to export. So this type of shapefile, simply export as a GeoTIFF file format. And further, we can easily work with ArcMap or QGIS software to make the this type of mapping. This type of mapping, just simply use ArcMap or QGIS software to visualize the urban expansion. Okay, as well as you can also make the urban spiral mapping. So this is another, if you check urban spiral mapping. So if you check, yeah, so it mainly show you the expansion in the different decade. Okay, if you check it, where is the more better map? Or this one. or this one you can see urban morphology, or this one is more better, I think. Yeah, so you can see this is the urban explorer for different year, urban expansion. So now it just simply make the combine. Okay, it's make the combine, suppose different decade combine. So in this case, suppose I want to combine this two decade I want to combine and make the urban spiral mapping. So how I can do it? So this thing you can easily do using ArcMap, or if you want you can also make it using the Google Earth engine. So let's go, I try to show you that. So for that you can simply apply a function in here. This function called the self max function. Okay, self max. And when I apply the self max function, then we just work with for single class, not binary class. So just I remove it not need. And I need to display the one color. So I need to display the urban area as a red color. Okay, as a red color, I just simply put the urban area red color. Same things you can also apply for 2013. Just apply the dot self max, and then I make the single class. So it's not need, just I remove, and I put the color another color. Suppose I display the another color for urban 2013. I put it, it's a blue color or yellow color. You can put any color, no problem. So now run the code. So now it work as a urban spiral mapping, and from this mapping we can easily get the idea. If you check, just only open this two layer. Okay, so we find out the red is indicating about the urban area 2023. You can see we find out the urban area 2023 as a red color. Okay, okay, so now you find out this type of yellow color urban in year of 2013. Okay, this type of urban is year of 2013, this type of yellow color, and this type of red color, it's the urban in year of 2023. So it's one kind of urban spiral mapping. So you can add the more other decade into different colors, then it will look more perfect. So when you make the research paper, when you make the research article, try to add the more decade and show the urban spiral or urban expansion. Okay, so this type of map called as the urban spiral mapping. So now this is the yellow color, this is the urban in year of 2013, and red color, it's the urban in year of 2023. Okay, okay, did you get the idea how to make the urban spiral?
Yes.
Okay, thank you.
Yes.
Or if you want, you can simply export this to layer as a GeoTIFF file format and further use the ArcMap software to create the more better map for your research paper. Look like this type of map, for adding the legend. Okay, for the different decade urban, simply add it. Okay, then it will look perfect for your research paper. Okay, so this is the way for the single class change detection. So in this time we are just work only for the urban. This process you can also apply for water body, vegetation, build up, same process. When you work with for the change vegetation change detection, just apply the same process for the single class change detection. So when you work with water body change detection, just apply the same. Okay, so now we talk about that multiple class change detection. Suppose at the same time I want to make the change detection for all of class I want to make the change detection. So it's called the multiple class change detection. So when we apply the multiple class change detection, then we need to apply first step is the reclassify. We need to make the reclassify. So in this case it will be start from 0, then 1, then 2, and then 3. This is my value. If you check build up, this is the 0, then 1, then 2, and 3. So now this type of value I need to reclassify. So 0 will be 1, 1 will be 2, 2 will be 3, 3 will be 4. Same, vegetation 0 will be 1, then water 1 will be 2, 2 will be 3, 3 will be 4. So this is the first step for reclassify 0 to 3 into 1 to 4. So for my case, because in this time 0 1 2 3, so I just like convert 1 2 3 4. Okay, then 1 2 3 4, I simply convert the value or reclassify the value. So this is the first step. So after reclassify, if you check, so just I take a variable, suppose before class, and also take the another variable after class. Okay, so in the before class I just put year of 2013, and after class I put the map land use land cover 2023. Okay, just I put the after class. This is the before mainly past. In this case past year is year of 2020, year of 2013. Okay, just I put the classified variable. This variable is stored the land use land cover map in year of 2013, and this variable is stored the land use land cover map in year of 2023. So just I reclassify using the remap function. Okay, using the remap function I just simply make the reclassify. So how I can reclassify? So just put the remap function and then apply the my previous value. Okay, previous value was 0 1 2 3, then I put the new value 1 2 3 4. So when I put the remap function and apply it on my land use land cover map, then this new variable stored the value 1 2 3 4. 1 is for vegetation, 2 is for water, 3 is for sand, 4 is for build up. Okay, simply it store it. Then same process also for the after class. So after class basically in year of 2023. So in 2023 it is stored in this variable classified 1. Basically this map land use land cover 2023, this map is stored in this variable. So I want to make the reclassify using remap function. This is my previous value 0 1 2 3, 0 1 2 3, just I convert into 1 2 3 4. Okay, for year of 2023, and store it in this variable after class. So now after make the reclassify, we simply make the changed and unchanged. Okay, so just I take a variable changed and put the after class mainly 2023, subtract with year of 2013. Okay, so now we make a change detection map. So it's called the overall changed map, overall changed and unchanged map. So now run the code. So if you check, it shows the overall change and unchanged. So white color, it means that there is no changed. Red color is indicating about the changed area and unchanged area between this two time period 2013 to 2023 in this study area we try to compute. So if you see, we find out this type of place, it shows the overall changed and unchanged map. Okay, so this type of white color, it's indicating about the unchanged area. Okay, suppose this place was built up in year of 2013 and 2023 it also built up, so there is no changed, and this type of red color is the changed area. Okay, suppose this type of place was sandland in year of 2013, but 2023 this place we find out the build up, so it's a changed. So now this map display the overall changed and unchanged map. Red color is the changed area, white color is the unchanged area. Changed and unchanged area you can easily find out. So now it's the overall changed and unchanged, not for only class, it shows the overall all of class including, and find out the changed and unchanged area. So we find out this type of white color is the unchanged area, there is no changed. Suppose this place was built up in year of 2013 and 2023 it also built up, so don't change. But suppose this type of red color, it was barren land or sand land in year of 2013, but 2023 it changed and make the build up, so it's the changed area. So this is the process to make the changed and unchanged map. Okay, but I want to calculate the transition. So now what is the transition? So transition basically Suppose in year of 2013 vegetation, how much area in vegetation in 2023? Suppose how much vegetation in year of 2013 convert into water in year of 2023? How much vegetation in year of 2013 convert into sand in year of 2023? Suppose how much vegetation in year of 2013 convert into build up in year of 2023? So it's called the transition. Not only for that, for the another class, water. So how much water in year of 2013 convert into water in year of 2023? How much area? Then how much water in year of 2013 convert into vegetation in year of 2023? How much water in year of 2013 convert into sand in year of 2023? So how much water in year of 2013 convert into build up in year of 2023? So this is the transition. Now let's check the another class. If you check for the sand, so same process. So in year of 2013 sand area convert into vegetation in 2023. How much sand area in 2013 convert into water in 2023? How much sand area in 2013 convert into sand area in 2023? How much sand area 2013 convert into build up in year of 2023? So this is the transition of sand land. So finally build up. So now build up. Suppose in year of 2013 build up, how much area convert into vegetation in year of 2023? And build up year in 2013 convert into water in 2023. Build up in 2013 convert into sand in year of 2023. Build up 2013 convert into build up 2023. So it's called the transition. Okay, so this type of transition now we compute, okay, for my study area. And if you check, we find out this type of 101, 102, 103, 104, then 202, 201, 203, 204. So basically this is the transition number. Suppose 101 its transition number for vegetation to vegetation, 102 transition number vegetation to water, 103 vegetation to sand. So for my study, because vegetation is the 1, then 2, then 3 and 4. So according to this serial, we simply make the transition 101, 102, 103, 104. So now how I can compute the transition? Okay, so for computing the transition, we are just applying a formula. If you check the formula, this is the formula for the calculated transition. This formula is that before class. I already make the before class. If you check, this is my before class. So this before class multiply with 100 and add with after class. So this is the formula for make the transition class. This is the formula to make the transition class. And I put the rename is a transition. Okay. So now if I print, then we can easily get the value, transition value if you check. So if you check, we find out the image, it's computing the transition. So if you check this transition, it contains the one band 1012404. Okay, so this is the transition we find out in here. So now from this transition, If you want, you can also add the transition band. Suppose just I add map dot add layer and I call the merge, and then I want to display, suppose mean it start, if you check it start from 101. Okay, I put here suppose 10101 and max 404. Okay, just I put here 404, and then I put it's a transition. So now run the code. So now it displayed the transitions. So it looked like that because I don't add the color. Okay, so we find out the transition map. Okay, suppose water to water, water to vegetation. So this type of including in here. Suppose I will show you the visualization. So for the visualization, I simply add the platelet and make the list. Suppose 101, it mainly vegetation to vegetation. So I will add the vegetation as a green color. Okay, then 102, 102 vegetation to water. So I want to display the water as a blue color. Okay. Then 103, what is the means about that? Vegetation to sand. So I want to display the sand as a yellow color. Then 104, I want to display the vegetation to build up. I want to display the result as a red color. Okay. Okay, if you want, you can also add the more other color. Then you can see the water to vegetation. So it's a green color. Okay, let me show you the result first. Just run the code and check the result. Because it's total 16 classes. Okay, total 16 classes. 101 to 404, total 16 classes. 16 transition classes we find out. Because we have total 4 class: vegetation, water, sand, and build up. So 101, 102, 103, 104, then 201, 202, 203, 204, then 301, 302, 303, 304, finally 401, 402, 403, and 404. So we have total this type of classes. Okay, that's why it also better you try to download this map as a GeoTIFF file format and further work with ArcMap software. Then it will be look more perfect. So in this time it will be start from the 101 up to 404 all of class. So you can also add the class all of class to display the transition map. Okay, or if you want, you can also download this file as a GeoTIFF file format, and further we can also make the map using ArcMap software to transition water to water, water to vegetation, vegetation to build up. So this type of classes we can also display. Okay. So let's go try to basically there's the total 16 classes. Okay, total 16 classes for transition. So I want to compute the area. Suppose this total 16 classes, I want to compute the area. This type of area, how much water convert into vegetation, or how much vegetation convert into water, how much vegetation convert into sand, how much vegetation convert into build up. So this type of classes I want to compute it. So let's go how I can compute this type of class. I will try to show you that. Okay, any question you can ask me about that? Any question or any confusion for the transition?
No, it's good.
Okay, so you also try to download the GOT file format about this file, then you can easily get the total 16 classes for transition. And further you can add the different types of color and represent as a map for transition. Okay, so now we compute the area. Suppose how much transition area we try to compute. Suppose water to water, water to vegetation. So this type of class we try to compute and check the result.